We're going to talk about limiting reagents, and we're going to use this video to fill out the first question on the worksheet. Okay, we start with an equation where obviously we have reactants and we have our products. And the limiting reagent is the one reactant that runs out first. So because it runs out, we no longer have enough of it to continue the reaction. For example, let's say that for the Super Bowl Sunday, you're going to make some hot dogs, okay? And you just happen to have, in this case, 5 hot dogs and 4 buns. Well, in reality, based on your ingredients, we can really only build 4 full hot dogs in buns, and we run out of bread, which is why that's your limit, and then we're going to have leftover hot dog, and that would be considered your excess. And that's kind of the same concept with actual equations. At one point you're going to run out of one of them, and so that's when your whole reaction stops, and it won't continue unless you have more of that particular compound. Okay, so you're going to look at the first question. It says, so let's say that you start with 14.8 grams of propane, which is right here. And you also have 3.44 grams of oxygen. Determine the limiting reagent. Okay, when you're doing problems like this, what you want to do is pretty much 2 mass to mass problems. One for the 14.8 grams of propane that are given to you, and the other one for the 3.44 grams of oxygen. Okay, so we're going to start with the first one, which is a 14.8 grams of propane. And what we're going to do is we're going to go ahead and use this amount to find out essentially how many grams of oxygen we would need based on having this amount of propane. Okay, so remember that this should be repeated diagonally. So this is going to be grams of propane. And just like I said before, grams are always per 1 mole of the same compound. So in this case, propane. Okay, so the molar mass of propane, I went ahead and pre-calculated those. Okay, so my calculations show that molar mass is 44.11 grams per mole based on 3 carbons and 8 hydrogens. Add them all up and that's what you get. So (44.11). Okay, so then because this was a grams and mole step, that means that this is going to be a moles over moles step. Okay, and it has to be diagonally the same. So this is going to be a propane, and when it's moles to moles, it can't be the same compound. It has to be the different compound. So it's going to be of the other compound mentioned, in this case oxygen. And when it's mole to mole, you want to make sure that you're using the coefficients. So for oxygen, the coefficient is 5, and for propane, the coefficient is 1. Okay, so I'm going to do a little bit of canceling. Grams of propane cancels with grams of propane. So moles of propane cancels with moles of propane. And we're at moles of oxygen. Okay, so since we're going to alternate the steps, it was grams and moles, now it's moles and moles, and now this is grams and moles as well. So we're going to diagonally cancel. So this is going to be moles of O2. Because this is a grams and moles step, that means this must be grams of the same substance, O2. And anytime we're working with grams, it's always per 1 mole. So this will be 1 mole, and then we're just simply going to use the molar mass of oxygen. Again, pre-calculate it at 32 grams per mole. All right, so from this point on, you're going to go ahead and multiply everything across on the top. And you're going to get 2,368. Okay, you're going to go ahead and multiply the bottom numbers. Obviously, anything times 1 is the same. So it's going to be the same, 44.11. Okay, you divide the two, top divided by the bottom. You're going to get 53.68 grams. I'm going to cancel that. It's grams of oxygen. Okay, so what this represents is the mass of oxygen that we would need in order to complete the reaction with this amount of propane. So I'm just going to write down that this is what we need. Okay. Now we're going to do the same thing, but we're going to do it with the other mass, which is a 3.44 grams of oxygen. So what we're going to find out is how much propane we would need if we were to use this amount of oxygen. So we start with the given, 3.44 grams of O2. And of course, it's a mass to mass. So you have your 8 boxes. Okay, so just like we did above, we started with grams. So diagonally, this is going to be grams of the same substance, grams of O2. Okay, just like above, it's going to be per 1 mole of the same substance, O2. And the molar mass of oxygen is 32. So that cancels with that. Okay, this step, if you recall, it's a moles over moles because it alternates. So it's moles over moles, and this has to be diagonally the same, so it's of O2, and this has to be of the other substance we're working with, which is propane, C3H8. Okay, so these numbers are going to be the coefficients. So propane is 1, so we put a 1, and oxygen is 5, so we put a 5, just like that. And again, that moles of O2 cancels with moles of O2. Okay, from this point on, our next step, since this was moles to moles, this is going to be grams and moles, but we have to make sure it diagonally cancels. So this is moles of propane per grams of propane. And of course, this is going to be 1 because anything with the molar mass is grams per mole, 1 mole. Okay, and as we had figured out before, propane, we said the molar mass is 44.11. Okay, so we're going to multiply across 3.44 times 1 times 1 times 44.11. Okay, once you do the calculations, that comes out to 151.74. You do the same for the bottom, so 32 times 5 times 1 gives us 160. Okay, so now you're going to divide the 2, and that's going to give us a grand total of 0.94. And let's see, these cancel, so we're left with grams of propane. It's grams of C3H8. And again, this represents how much propane I would need with the amount of oxygen given. Okay, so these guys right here represent how much we would have. So that represents that we have 14.8 grams of propane and that we have 3.44 grams of oxygen. Okay, and again, this represents what we need. So now we're going to compare it. If we have 14.8 grams of propane and we need 0.94, we're going to have more than what we need. So what we need is less and what we have is more. So that's not our limit. Okay, and in this situation we have 3.44 grams of oxygen, so that's how much we have, but we need 53.68 grams of O2. So as you can see, what we have is not enough of what we need. So when we don't have enough, that means that that is going to represent our limit, okay, because we don't have enough. So to answer the question, determine the limiting reagent, our answer is simply going to be O2, because that happens to be the one that we don't have enough of. We just ran out. Okay, we need to know this before we can do any of these. So and then it says determine the number of moles of carbon dioxide produced, and that's where we start using the amount of our limit. Okay, so for this problem we use the amount of the limit, which is 3.44 grams. And it says to determine moles. So this is going to be a mass to mole problem. Okay, so then that diagonally has to be the same. So that's grams of O2 per moles of O2. Okay, we know that the molar mass of O2 is 32. If you forgot, don't forget that it's been pre-calculated as that. Okay, so that cancels with this. We're left with moles of O2, which means this has to be, since this was grams and moles, this has to be a mole over mole step, with this being diagonally the same. So that means this is going to be moles of the other thing we're trying to find, which is carbon dioxide, so CO2. And anytime we have moles and moles, we use the coefficients. So CO2 is 3, so therefore that has a 3 there, and O2 is 5, so that has a 5 there. Moles of O2 cancels with moles of O2. So now we're going to multiply across 3.44 times 1 times 3. Okay, and that's going to come out to 10.32. We do the same on the bottom. So 32 times 5, that's 160. Okay, we divide the 2, and it gives us 0.06 and moles of carbon dioxide. Just like that. Okay, for the next one, it says determine the number of grams of H2O produced. And just like we did before, it was important for us to find the limit. Otherwise, we couldn't do the rest of the problems because we have to use that amount. So if, let's say, propane would have been our limit, then we would have been using the 14.8 in the rest of the problems, but that wasn't the case. Okay, so we start again. 3.44 grams of O2. Okay, so it says determine the grams of H2O. So our given is grams, they want us to find grams, so it's a mass to mass. So you kind of can figure out how many little boxes you need. Okay, that's grams of O2, which means that this is going to be grams of O2, and this is going to be per 1 mole of the same substance, and grams is 32. Okay, because that was a mass to mass step. Let me go ahead and cancel these. Or I'm sorry, a mole to gram step. That means this will be moles over moles. And it'll be diagonally the same substance, and then up on top will be the one they're looking for, which is H2O. Because it's moles over moles, that means we're going to use the coefficients. So the coefficients again for water, they're 4, or it's 4, and then for oxygen, it's 5. So that cancels with that. Okay, so now since we did a mole and mole step, the next one has to be moles and grams. So moles will diagonally come here. This will be grams up here, and it's got to be of the same substance. So H2O, H2O. Okay, it's always with 1 mole for a molar mass, and grams of H2O is 18.02. Okay, so you're going to go ahead and multiply across, and that's going to give you 247.96, and then you multiply that 32 by 5 times 1, that gives you 160. So now you take the top divided by the bottom, and it's going to be 1.55. And if moles cancels with moles of H2O, you're left with grams of H2O. Okay, so based on the limit, that's how many grams of water would be produced. Okay, so then the last one says determine the number of grams of excess reagent left. Remember, like the hot dogs we were talking about, how one hot dog was left over. So now we're going to have to figure out how many grams are left over. Well, that one wouldn't be so hard because we kind of already have most of the work done. So remember that our limit is O2, but our excess is propane. Okay, so if we have 14.8 grams of our excess, so that's how much we have, 14.8 grams of our excess. We're going to go ahead and subtract from the amount that we need. So we need 0.94 grams of our excess. Okay, so you're going to subtract the 2, and you're going to have 13.86 grams of propane. And that's going to be, again, our excess left. Okay, so that's pretty much what you do for limiting reagent problems. So you start with mass to mass problems, and they can ask you numerous questions on how much was left or how much was produced, and that's what we did here. So as you get ready to do your own by yourself, remember you have 2 numbers just like you started here, and you're going to go ahead and do a mass to mass problem just like you did up here. So the 25.4 grams, for example, would be here. You would do that mass to mass and find out how much you need of the other one. Same thing with the 10.2 grams of iron. You would put it here, do a mass to mass until you find out how many grams of the other one you need, and then you decide which one is your limit. Once you decide which one is your limit, then based on that, that's the one you're going to use for the rest of the problems. So you're going to decide, am I going to use 25.4 for the rest, or am I going to use 10.2 based on which one is the limit? Okay, so you can go ahead and obviously go back and look at the video to see what you could have missed, but that's pretty much how you do the problem. All right, so once you're finished with these, you're going to go ahead and turn it in before you leave today.